Hello everyone, it's Mel here. Thanks for tuning into this presentation of my article titled Onward and Upward, Adapting to Climate Shifts Through Assisted Tree Migration and the Evolution of Forest Policy in British Columbia. The article and presentation were done for FRST 144, Forest Resources Admin with Stacy. I'll start this presentation by introducing what I've chosen to research and follow with defining the assisted migration concept. I'll share my findings about why we need it and how it's executed in our province of BC. There are some policies surrounding this, and I'll talk about that too. I'll finish with a look to the future, just regarding policy, and also a bit from an ecological perspective, and there's a fun little map that we'll go through and talk about some predictions. As our climate in British Columbia changes, we see the BEC zones change in size and shape. Over time, some will give way to entirely new zones, disappearing completely. Canadian forestry is adapting, using the climate-based seed transfer model to assist with the migration of timber trees. Forest policy remains in a fluid state to accommodate the changing environment. So what I'm saying here is that the climate change issue is quite real in BC. We're seeing it happen before our eyes in some cases with these violent wildfire seasons that are pretty much new normal at this point, and drought events that are threatening large forested areas. Some trees are no longer thriving in their traditional zones. In the past, we've had forest policy that's been written without climate change in mind, so we're seeing a shift now to give a little more rein to forest professionals to be more fluid in writing their silviculture prescriptions. Okay, so let's get into what assisted migration is and why and how it's employed in the forestry industry. Assisted migration refers to the deliberate and human-assisted relocation of species, particularly plants or animals, to new habitats to help them adapt to changing environmental conditions, often due to local climate change. This concept was first introduced in 1985 by two bioscientists during the greenhouse effect days, when they proposed that trees may not be able to keep up with the pace of increasingly warmer seasonal cycles. And I just want to say their names because these two people did a great service to environmental science. It was Robert Peters and Joan Darling, and they addressed a lot of environmental challenges and also a lot of solutions that were largely not heard by industry at the time. Their paper is called The Greenhouse Effect and Nature Reserves, and it's actually kind of a thrilling read if you're into this sort of stuff. So there are three different types of assisted migration that we normally see within the forest industry. They're ordered from low to high risk, left to right here on this figure on this slide. First, we have the low-risk assisted population migration, which is a movement of trees well within their ranges, just into different areas. This is seen with the most occurrence and is the safest way to move trees around. The second type is assisted range expansion, and here we see established range with outliers. We can move the trees into the outlying areas where we assume that they will still grow and thrive. This comes with a little bit of risk as it's starting to creep out of the tree's normal range, but still not super risky. This is practiced with a bit more caution, but we can certainly see it in certain areas where climate change is quite evident in BC. The third type is the assisted species migration, and this moves trees completely out of their range across natural migration boundary. And this is normally quite risky. However, we're seeing good results with the planting of western larch, which is native to southern BC and the northern Pacific Northwest. And this western larch has been planted in north and central BC to replace lodgepole pine stands that were decimated by the mountain pine beetle. And these results are paving the way for more trials around the province and implementing this into silviculture prescriptions as a general guideline. So why do we need assisted migration? Well, I think we actually have kind of answered this question already, but I've got the slide here, so let's go for it. Trees have been migrating themselves into areas better suited to them since they started competing, basically. It can sometimes take as little amount of time as a decade. It can take up to centuries, just kind of depends on the tree and its climate. With the climate changing so quickly, we don't really have the luxury of time anymore. So it's necessary to help these trees along with more forward-thinking silviculture prescriptions and these seed transfer models, lest these trees become mismatched in their climatic niches, which you can kind of see a general outlook of that on the figure on this slide. In forestry, we use these seed transfer guidelines to adhere to the forest policy that's been written. Basically, this means that there are certain rules governing the placement of certain seed lots into specific areas. And as a forest professional, you can be disciplined for not following these guidelines. Under the Professional Governance Act pertaining to due diligence, and also the FPBC can get involved to give a reprimand. There used to be the geography-based seed transfer model, and that was largely used until about 2018 when there was a transition to the climate-based seed transfer model. And the climate-based seed model gives a bit more rein to the forest professionals, and they can use the climate information and the guidelines to help them in their planting prescriptions in the various parts of BC where reforestation happens, which is vast across the province. It's everywhere. So what is next for all of this? I think we're going to see a different species climb the ladder in BC as things quite literally heat up. Probably a shift from western hemlock as the most common tree to Douglas fir and western larch. It's kind of hard to predict exactly what's going to happen because climate change is still a bit of a dark topic. We've never really seen human-induced climate change on this scale before, so it is hard to say how severe and where these changes will keep occurring. We'll see more yellow pine planted in the wildfire-prone areas, I think, and in the attempt to prevent major fire spread events, this is what is going to have to happen in silviculture prescriptions, is these more fire-resistant trees. And again, yeah, I think that western larch will probably come out on top as the most common timber species in the BC forest industry, with Douglas fir not far behind. So as we're talking about predictions here, I've got this map that I used from the UBC wiki page for assisted migration. How I interpret it is the Beck zone map currently on the left, and then predicted into the 2080s on the right, which is about a rotation's length away from right now. You can infer a lot of stuff off this map. And if you are interested, I encourage you to pause the video and make your own predictions for which trees should get planted where right now to ensure that we have harvestable timber in the next large rotation. I don't totally agree with a few things on this map, but of course it's a prediction. I don't really agree with the expansion of the ICH with such largesse. I think it will creep north and it'll waver on the outer edges of it where it'll give way to IDF and Ponderosa zone in the southern areas. And speaking about the IDF and Ponderosa zone on here on this predicted map, I think it's bang on with the trajectories that they're thinking. And if we remember what Caden said about the Beck zone map in ecology class, you really can look at this map when you're thinking about climate change and look at it like a heat map. So that's all I've got for you. I'm open to any questions and I will do my best to answer them, as this topic is of a genuine interest to me and I have been learning a lot about it on my own as well in the last year. Thanks a lot for listening, and I'm looking forward to some of your feedback.